In this lesson, we're going to talk about how to do horizontal translations and vertical translations on sine and cosine graphs, and then we're going to combine those and do them both at the same time. So here we go. Just kind of as a review, we learned in the last lesson that when you have a coefficient in front of your function, that affects the amplitude. So it's like a stretch or a shrink of the graph. It's like a vertical stretch. But if you have a number plugged inside the function, like here, like this f could be a sine or a cosine, and the b would be the coefficient of the x, and notice it's in a different position from the a number. When you have a number in this b position, that affects the period of the graph, or it's like a horizontal stretch or shrink. Now, we can just have the graph move horizontally along the x-axis, and when the graph moves horizontally, that's called a phase shift, and the number that affects that is a number that's added or subtracted inside the argument of the function. And we can also have a vertical shift where the entire graph is not stretched, but it's just moved up or down along the y-axis, and that will show up as a number that's added to the function. Notice that when it's a horizontal, it's added inside, and when it's a vertical translation, it's added on the end. Okay, let's talk a little bit about horizontal translations. If you have a function that has x minus d plugged into it, this graph is going to move horizontally d units in the opposite direction of the sine. For example, if this is f of x, and this is not a trig function, but that's okay, just any old function. If this is f of x, then f of x minus 4 will move it 4 units to the right. See, it's the same shape, it's just moved over. And f of x plus 3 will move us 3 units to the left. So the middle is here at -3. Now notice that the signs work backwards from the way you probably think they ought to. The plus 3 actually moves us to the left, and the minus 4 actually is moving us to the right. So if you'll just use the opposite sign here, it'll tell you which way to go on the x-axis. Now let's talk about sine of x specifically. We know that the period of sine of x is 2 pi. That means that as x goes from 0 to 2 pi, the sine graph goes through one complete cycle. We learned that last time. Now sine of x minus d is going to complete one cycle as x minus d goes from 0 to 2 pi. So we can find phase shift if we take x minus d and set it equal to 0 and solve that for x. And that will tell us the phase shift, and it will also tell us where to start the graph of sine of x minus d. So let's take a look at y equals sine of x minus pi over 3. So first, let's pick up on the amplitude. We know that the coefficient of the sine function here is 1, so the amplitude is 1. And b is also 1. b is the coefficient of x here, so b is 1 as well. That means the period is 2 pi. Now, if I take my x minus pi over 3 and set it equal to 0, I can see that the first wave, the cycle, has to start at pi over 3. So the phase shift is pi over 3 to the right. So notice that the negative sign here indicates that the phase shift will be to the right, and when you solve it, you see that the phase shift is positive, so that's to the right. Now pi over 3 is the starting place, so here I've put a mark on my axis for pi over 3, and now I'm going to lay out my next 4 marks, and I need to figure out what is the ending place of this cycle. So the ending place would be the starting place plus the period, because it takes 2 pi radians to get from the starting place to the ending place. So whatever the starting place is, that plus the period should tell you where it stops. So I'm going to do pi over 3 plus 2 pi. Now this is a fraction, so we need a common denominator. So I'm going to multiply top and bottom by 3 here, and that's going to make pi over 3 plus 6 pi over 3. Now 1 plus 6 is 7, so that's 7 pi over 3. That means the ending place here is 7 pi over 3. Now let's use the shape of the graph to lay out our dots. We know that sine is middle, high, middle, low, middle. So middle, high, middle, low, middle. And connect the dots. And that's exactly what that graph needs to look like. Now let's look at y equals 3 cosine of x plus pi over 4. First of all, I see that a is 3, so the amplitude is 3, and b is 1. So the period is 2 pi over b, so the period is 2 pi. Now let's take our x plus pi over 4, set it equal to 0, and solve it for x. And we can see that the phase shift is pi over 4 to the left. The starting place is negative pi over 4. Okay, so I set my negative pi over 4 right here. And now let's find the ending place, because we know that the ending place is the starting place plus the period. So negative pi over 4 plus 2 pi is going to be negative pi over 4 plus 8 pi over 4. See, I used a common denominator to change 2 pi into fourths. So I multiplied the top and the bottom by 4. And now the ending place I can see is 7 pi over 4. So I know that that ought to be out here somewhere, but I am not quite ready to lay down my 4 marks because I don't know where the first mark should go. Should it be on the y-axis, or should it be to the right of the y-axis? And we really don't know that yet. So let's see if we can find where that first mark goes. I'm going to have to start by finding the middle. So remember, we did this in the last lesson. To find the middle of a cycle, we take the starting place plus the ending place and divide by 2. So negative pi over 4 plus 7 pi over 4 divided by 2. So in other words, we are averaging the start and the end. So negative pi over 4 plus 7 pi over 4 is 6 pi over 4 over 2. Now, divided by 4 divided by 2 really just means divided by 8. So 6 pi over 8 simplifies to 3 pi over 4. So I know the middle now is 3 pi over 4. And now I'm going to average the starting place plus the middle to find the first quarter. So we'll do negative pi over 4 plus 3 pi over 4 all over 2. That averages together to make 2 pi over 4 all over 2. And so, of course, that's 2 pi over 8, which reduces to pi over 4. So it looks like our first mark does belong on the right side of the y-axis, and it should be as far away as the negative pi over 4 is from the y-axis. Now I can go ahead and lay out my other 3 marks about the same distance apart as my first 2 marks. And we know that the ending place is 7 pi over 4. So here's the starting place. We had to do a little work to figure out where to put the first mark after the starting place, but after that we can just go, mark, 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 and then we know that the end is 7 pi over 4. I did not bother to label the third quarter, and we could write 3 pi over 4 here on the middle one if we wanted to. But we really I don't think we need to find the third quarter right now. So let's go ahead and lay our 3 marks along the y-axis, and we know that cosine goes high, middle, low, middle, high. So I'll put my first mark right here. See, it needs to be it's not starting on the axis this time, it's phase shifted. So it's starting here, but it's going to start high. So I'm going to have a dot right here, high, and then this one is going to be in the middle, and then this next one is going to be low right here, and then we'll have another one in the middle, and then another one high for the end. So if we connect those dots, there's our cosine graph. And you can see it starts just a little bit to the left of the y-axis. Now, you know we're always looking for shortcuts when we do things in trigonometry. So as long as b equals 1, you really don't have to solve that equation for d. You know that the phase shift will equal d. But if you have bx minus d, and b is not equal to 1, then the phase shift is not d. In other words, if you have a coefficient in front of your x, then d is no longer the phase shift. So then it's really important for you to solve that equation. So you just take what's inside the parentheses, the bx minus d, set it equal to 0, and solve it. So let's look at one like that. Here I have -2 cosine of 3x plus pi, and we're going to do this one over 2 periods. So first, I know that a is 2, and I know that there's going to be a vertical flip. And I also can see that b is 3. So the period is 2 pi over 3. Now, let's take our 3x plus pi and find the starting place for our first cycle. The 3x plus pi equals 0. I'll subtract pi from both sides and divide both sides by 3, and it looks like our starting place is going to be negative pi over 3. Or in other words, pi over 3 to the left. Now the ending place, I need to take the starting place and add a period to that. So negative pi over 3 plus 2 pi over 3 would be positive 1 pi over 3. So our ending place is there. Now when I lay out my first mark, negative pi over 3, the ending mark just happens to be at positive pi over 3, so I know it's the same distance away from the y-axis as the starting place was. See, it just so happens that it's the negative and positive of the same two numbers, so it really wasn't hard to know that the middle mark would fall on the y-axis. Now, let's lay out our dots. We know that this is phase shifted and that amplitude is 2. So here I've drawn my amplitude of 2. I meant to say vertical flip. It's vertically flipped and the amplitude is 2. So our first dot is going to go at the starting place in the low position. Remember, cosine is high, middle, low, high. But if it's flipped over, it's low, middle, high, middle, low. So first dot here, low. Second dot, middle. Third dot, high. Then middle, and then low. Alright, now our second period, we'll just lay out 4 more marks. And I need to label this ending place out here. So I'm going to do pi over 3 plus another period. So pi over 3 plus another 2 pi over 3 gives us 3 pi over 3, which is pi. Alright, so pi goes right there. And so we're going again, we're already low, so the next mark's middle, high, middle, low. And connect the dots. And there's 2 cycles of -2 cosine 3x plus pi. Now, if the argument is in this factored form that you see here, where the b is factored out, and in parentheses you have x minus d, then you don't have to solve the equation to find out the starting place. You just can know that the phase shift is d, the number you see here, and the sign is going to be opposite. So, like negative is going to mean to the right, and positive is going to mean to the left. Always backwards. Horizontal stuff's always backwards from the way you think it ought to be. So we're going to see an example of that in the next example. Now we're going to talk about vertical translations. If you have a number that's added to the rest of the function, this is usually called C, and this indicates a vertical shift. So what you're doing is you're taking the y coordinate that you would have had before and just adding or subtracting onto that. And so what that does is it moves the whole graph up or down. If C is positive, it moves the whole graph up. Like you can see here, they've got 3 plus f of x. So if f of x is the blue line, and it goes right here through the y-axis, then if we go 1, 2, 3 up from that, that's going to be 3 plus f of x. And if you have your graph here and you do negative 5 plus f of x, well, that's going to move everything down 5. So your graph would end up being here. So this is negative 5 plus f of x. So let's go ahead and look at y equals 3 minus 2 cosine 3x, and we'll do it over 2 periods. First of all, I can see that this negative is going to indicate a vertical flip, and then a is 2, so our amplitude is 2, and the b is 3. You can see the b number here, so period is 2 pi over 3, and then vertical shift is going to be 3 up because of this positive 3 right here. So that means that everything's going to be moved up 3. What I'm going to do is draw 3 tick marks on my y-axis, and this is going to become the middle of our new graph. So I'm just going to sketch a horizontal line right there because that's now the middle of our graph. See, the middle used to be the x-axis, but now we're going to move everything up 3 units. So if amplitude is 2, that means I'm going to need 2 tick marks above the middle, and we also already have 2 tick marks below. So I don't always do this, but for this time I'm going to draw in little guidelines to help us remember that this is the highest point and this is the lowest point on this graph. Alright, now there's no phase shift here. So what we can do is just go ahead. We know that the starting place is going to be on the y-axis. We'll go ahead and lay out our starting mark plus 4 more marks. And then because they've asked us to draw 2 periods, let's lay out 4 more marks after that. Now the end of the first cycle is 2 pi over 3, and then if we add another period to that, the end of the second cycle is 4 pi over 3. And I've just moved my little tick marks up here on the middle line because it's just easier sometimes to graph if the tick marks are where you're trying to draw. So let's see. We are now ready to put dots down, and so let's think about our basic shape. This basic shape is cosine, which is normally high, middle, low, high, but this one's been flipped over, so that's going to make it low, middle, high, middle, low. So with no phase shift, I start on the y-axis at the lowest point, so that's going to be here. I'll put a dot low, then middle for the next quarter, then high, then middle, low. And our second cycle is going to follow the same pattern, so low, middle, high, middle, low. And let's just connect the dots. And that graphs 2 periods of 3 minus 2 cosine 3x. Alright, let's take a look at negative 1 plus 2 sine of 4x plus pi over 2 periods. So I see that amplitude is 2, and there's no vertical flip in this case. B is 4, so it's not factored out, so I'll have to calculate the phase shift in just a minute. But let's go ahead and get period, which is 2 pi over 4, where that will reduce to pi over 2. So period is pi over 2. And then our vertical shift is down 1. Okay, so I'm going to go ahead and draw right here on my y-axis down 1, and that is the new center of our graph. Let's just draw a little horizontal line there to help us remember. And since the amplitude is 2, I'm going to need to go up 2 and down 2 from that point. So from negative 1, if I go up 2, I'm at positive 1, and from negative 1, if I go down 2, I'm at negative 3. So there are our guidelines again for the lowest point and the highest point. And there is a phase shift this time. So we'll calculate the starting place of our graph is where 4x plus pi equals 0. That means that when x is negative pi over 4, that's the starting place of our first cycle. So here is negative pi over 4. And the ending place of our first cycle would be negative pi over 4 plus a period. So negative pi over 4 plus pi over 2 would give us positive pi over 4. And I didn't have to do a lot of fiddling around to figure out where the middle was, because our starting place and ending place happen to be the same number, just negative and positive. It's easy to see that the middle mark will go right on the y-axis, right in between them. So I've gone ahead now and laid out my 4 more marks for my second cycle, and the end of the second cycle is going to be pi over 4 plus another period. So pi over 4 plus pi over 2, if you use common denominators, is going to give you 3 pi over 4 for the end of the second cycle. Okay, now let's think. We know that this is a sine graph, so the pattern is middle, high, middle, low, middle. We also know it's been moved down 1, so this is now the middle, and we're supposed to start at negative pi over 4. So we'll start right here. This will be the first dot, and then the second dot will go here, but at the high point. Okay, this is the x value of it. So at the first quarter we go high, and then in the middle we go back to the center of the graph, and then for the next quarter we go low, and then for the next quarter we go back to the middle. So you can see middle, high, middle, low, middle, and then let's do that again. Middle, high, middle, low, middle, and connect the dots. And there is the graph of negative 1 plus 2 sine of 4x plus pi. You can see that the center of the graph is down 1 from where it was before, and it's also moved horizontally to the left pi over 4 units. So we end up starting here, and if we go 2 periods, we end at 3 pi over 4. Now here we have another example of a function where b is factored out. So that's going to make it easy to find the phase shift. We'll go ahead and say that a is 1, and we also can see that b is 2, and we also can, well, let's go ahead and do the period. Period is 2 pi over b, which is 2 pi over 2, so period is pi. And let's go ahead and get the vertical shift. Vertical shift is up 1/2. Now, I've drawn on my y-axis 1 and 2. And then at the 1/2 mark, I've put a horizontal line because we know that our vertical shift is 1/2. So this horizontal line represents the new center of our graph. Now I'm going to go ahead and draw guidelines for the top and bottom of our graph as well. If you take 1/2 and you add the amplitude to that, 1/2 plus 1 would be 1.5. And if you take the center of our graph and subtract the amplitude, 1/2 minus 1 would be negative 1/2. So that's going to be the low point. Now let's go ahead and get phase shift. You can look at the graph and see that phase shift is pi over 4 to the left. Because remember that if you took x plus pi over 4 and set it equal to 0, then to solve you'd have to move pi over 4 to the right side of the equation and it would become negative. You can just see that when you look here. So pi over 4 to the left is our phase shift. Now because we have shifted to the left, it's a little stickier to try to figure out where to put the 4 marks. So let's go ahead and figure out the ending place of our graph. we know the ending place is going to be starting place plus period, so negative pi over 4 plus a period. We need common denominators, so it's going to be negative pi over 4 plus 4 pi over 4, which is going to make 3 pi over 4. I still don't know, though. I know 3 pi over 4 is out here somewhere, but I don't know where to put my first mark. So let's go ahead and figure out the middle of our graph. For the middle, if we average the start and the end, do start plus end and divide by 2, we'll get 2 pi over 4 all over 2, which reduces to 2 pi over 8, which reduces to pi over 4. And then, well, I can see that the middle goes about pi over 4. Now, you may be able to see now that the first quarter mark is going to have to go right on the y-axis, but let's calculate it. The first quarter is going to be the starting place plus the middle, all divided by 2. So, of course, the start plus the middle adds up to 0, so the first quarter mark goes at 0. So once I get that first quarter mark, then I can do middle, third quarter, and end with no trouble. And the ending place is at 3 pi over 4. Now we're supposed to draw 2 periods, so let's go ahead and add another period to that, and makes it 7 pi over 4, because 3 pi over 4 plus pi would be 3 pi over 4 plus 4 pi over 4 would be 7 pi over 4. So this is the end of the second cycle. Now, we're ready to put down the dots. We can see that the shape is middle, high, middle, low, middle. And we can also see that the phase shift we know is negative pi over 4. And this needs to be the new center of our graph at y equals 1/2. So the first dot goes here. And then high, at the first quarter mark we go high. At the middle mark we go back to the center. At the third quarter mark we go down low. And at the 3 pi over 4 mark we go back to the center. Alright, now the next cycle is going to go middle, high, middle, low, middle all over again. And we are ready to connect the dots. And here's our last one together. We've got negative 5 over 2 plus cosine of 3 times x minus pi over 6. And again, we're going to do 2 periods. So I can see that A is 1, because remember A is the coefficient of your function. B is 3. That means period is 2 pi over 3. And vertical shift is 5/2 down, or 2.5 down. Phase shift, you can look here and see that it's pi over 6 to the right. Because remember, this horizontal control works backwards. So negative actually means to the right. Now let's go ahead and calculate the ending place of our first cycle. If we take the starting place and we add a period to that, we'll need common denominators. 2 pi over 3 becomes 4 pi over 6. And so pi over 6 plus 4 pi over 6 makes 5 pi over 6 is the end of the first cycle. Alright, I've gone ahead here and I've drawn wide marks for our whole numbers, and since we're dealing with halves, I went ahead and drew half mark, little marks for the halves. So negative 1, negative 2, negative 2.5 is going to go right here. And then we know that amplitude is 1. So if I'm at negative 5/2 and I go up 1, that puts me here at negative 3/2. And if I'm at negative 5/2 and I go down 1, that puts me here at negative 7/2. Alright, now here is positive pi over 6. It's easy because the y-axis is not in the way. It's easy to lay out the next 4 marks. And we know that the end of the first cycle is 5 pi over 6. Now let's go ahead and figure out the end of the second cycle. So we'll do 5 pi over 6 plus another period. It's going to be 5 pi over 6 plus 4 pi over 6. That's 9 pi over 6, but that will reduce to 3 pi over 2. So the end of our second cycle right here is 3 pi over 2. Now let's go ahead, and we know this is the middle of our graph and the phase shift is pi over 6, so our first dot, well, let's see, cosine is high, middle, low, middle, high, so we need to start at the high mark at pi over 6. So our first dot's going to go right here, and then our second dot is going to go middle, and then third dot goes low, and then middle, high. So high, middle, low, high, and then repeat the pattern and connect the dots. That's all it is.